Hey friends, welcome to One Little Coder. In this Python NLP tutorial, we're going to learn how to do few short text classification with SetFit. First, we're going to start the video with understanding why do we need few short, then we are going to get into the code. First, if you have never heard about few short or zero short, a quick primer. If you do not have any training data at all, and then you want to build a text classification or a machine learning model using some sort of pre-trained model, which is also called as foundation model these days, then you can use a technique called zero shot text classification or machine learning model. If you have got little bit of text, you've got a little bit of training data. In the first case, you didn't have any training data at all. Now you've got a little bit of training data, but you don't have enough training data to train a deep learning model or a classical machine learning model, but you want to aspire to have that kind of outcome. So your pre-trained model, completely zero shot, is not helping you with your particular domain, and you do not have a trained model for your domain. So you want to take some sort of zero shot, and then you want to fine tune your model on top of it, fine tune your data on top of that zero shot model. And this is what we call as few shot when you have very few training data set. And we are going to see in this example how to do few shot text classification with SetFit. Now, why is the name SetFit? So this is developed by Moshe Wasserblatt. So you can check this blog post for more details. So the name SetFit comes from sentence transformers fine tuning. So you're actually taking a sentence transformer, which is also popularly known as SetBird these days. So you can take this sentence transformer model, and then you can use that to fine-tune the model, fine-tune the embeddings, and then on top of that you would finally build a logistic regression, and then you fit it. So this is what SetFit is. You should definitely check out this blog post where they actually show how this SetFit model even outperforms GPT-3 on few shot classification. So this is very important for you to know that what you're building is not some prime model, but it's not a superficial model. It's actually a model that competes with state-of-the-art model. So that's something that for you to keep in mind. Now, are we going to do the entire thing? Are we going to take a base sentence transformer model, fine-tune the embeddings, fit a logistic regression on top of it, get the final output? No, we are not going to do all of those. If you want all of those, then you can go to this blog post and learn about it. But to keep it simple, some kind soul has already created a abstraction, the Python package on top of it. So we're going to use that Python package called SetFit to do what we want to do now, which is text classification. We're going to do simple sentiment analysis, sentiment classification using few shot methodology, few shot machine learning. So now that is all about zero shot, few shot. What are we going to do in this video? So to get started, I would like to start with a Kaggle notebook. So we have got a data set already. You can do this completely on Google Colab. So the entire reason I've selected Kaggle notebook is because we have a data set available, and then we can also see the scores and benchmarks and all those things. So I've taken a Kaggle data set, and on top of that, I've created a new notebook. And inside the notebook, I've just imported very basic information, which is NumPy in this case. So let me run it, and you can see that it has got three files: sample submission.csv, train.csv, and test.csv. Now, what's our data set? Our data set is simple movie review data set. Like, you have got movie reviews, and then it has been labeled as positive, negative, extremely, I think somewhat positive, somewhat negative. Let's see. Now I'm going to read those, and then I'm going to display the head of it. So you can see that there is a phrase ID, there is a sentence ID, there is a phrase, and there is sentiment. And if you see sentiment, you might just on top of it, if you see, you might assume that it is just two classes, but it's not two classes. So when I do sentiment values count, you can see that it has got 0, 1, 2, 3, 4. So you've got multiple classes. Now what are we going to do? Now we are going to say 0 as negative and 4 as positive. And for this particular exercise, I want to do only binomial classification. So I'm not going to do multi-class classification. I'm going to simply keep 0 and 4, which is positive and negative. So first we are going to copy the data set. You can see I'm taking train and copying into something called train_form, because I'm going to format it. That's why I wanted to call it train_form. Now I'm going to take this 0 to 4, and then I'm going to call it sentiment. There is a new column, sentiment, and that we're going to use the existing column sentiment, and then we're going to create a new column called sent_full, just to say that it's a full form, and then we're going to label it from negative, somewhat negative, neutral, somewhat positive. So we're going to go all the way from 0 to 4, and then we're going to assign it in the column called sent_full. Now when I run when I take this train_form, you can see that we have sent_full and also sentiment, which is equally mapped from 0 to 4. Now, like I said before, for this exercise, I want to keep it only, a class variable with 2 values, just a simple binomial classification. So I'm going to keep only positive and negative. So which means from train_form, I'm extracting positive or negative. It could be either positive or negative, nothing other than that. I could have also, labeled somewhat negative as negatives, somewhat positive as positive, but I didn't want to do that. I want to take purely 0 and 4. This is something that I have done a lot in my career. Like whenever we have used to use 5-star scale, so it's always an ambiguous thing. People usually give 1, 2, 3, 4, 5. So most of the time what I used to do is I used to deal with only 1 and 5, because that's highly opinionated pieces, like 2 and 3 and 4. Those are not highly opinionated. People wanted to play safe, so I would always deal with 1 and 5. So I've used the same approach here as well. But if you want to change it, you can take you can take somewhat negative as negative, you can take somewhat positive as positive. It's completely up to you, and nobody's questioning you what to do. It's just a matter of different approaches based on how do you want to train your few shot classification. So now I've created a new dataset which says train_pos_neg, just to say that this is a training dataset that has only 2 classes, positive and negative. At this point, we have got enough data. Like for example, we can actually train a machine learning model from scratch here. We have got that much data. Like we have got 16,000 rows. But just to demonstrate what I want to do, which is few shot learning here, I don't want to take the 16,000. The whole point of few shot is you don't have enough training data. You have very minimal training data, but still you don't want to just simply go with 0 shot, a pre-trained model. You want to fine tune on top of it. And that's exactly why we got into few shot text classification. So what I'm going to do now is I'm going to take this data set and then sample only 100 rows, 100 data points. So that 100 data points are going to be simply our training data set, and we are going to train our model, or using SetFit, we are going to fine tune the existing sentence transformer embedding using this 100 data points. That's quite important. What I'm actually doing in my case is I'm kind of emulating a scenario where I do not have enough data. But in the real world, you would often come across this kind of situation where you don't have training data. You would either go to Amazon Mechanical Turk, or you have got an intern who would hand label the data, or even you yourself as a data scientist would hand label the data. And after hand labeling, you're not going to do hand labeling for the entire 16,000. You're going to do hand label for a couple of hundreds or even less than 100, and then you would try to fine tune it. And that is the situation that I'm trying to emulate here. So that's exactly why we are going with 100. So I've created a data frame called train_100, and I've got another data frame called train_50. I can load 50. So this is what we are going to use to do the few shot classification, and this is the data frame where we are going to actually predict the outcome and then compare the outcome. Now our training data preparation is finished. We're not going to do anything at all from the data preparation. So now at this point, we are going to install the library that we want. This library does not exist in PyPy, so you have to install it from GitHub. So I'm going to just do pip install git and then install the required library. And after I install, it's installing. You cannot see what is happening because I'm installing it in quiet mode. But after I install, then we are going to load from SetFit. We're going to import the SetFit classifier. So the good thing about SetFit library is that it follows a very scikit-learn API. That's something that I love about it, because it's very easy for anybody who has done normal machine learning, classical machine learning, to just simply take it and then start using it for their own code. So that's a really good thing. So the next thing that we are going to do after it gets installed, we're going to import from SetFit, import SetFit classifier. So the next thing is you need to decide on a model. So it's done. Let me load it. So the next thing is now you need to take a sentence transformer model. So if you go to sentence transformer or sbert.net website, you would see a lot of sentence transformer models. So you can pick something that makes that connects with you. Not mentally or heart-to-heart connection. So that connects with the purpose of what you are trying to do, the NLP NLP task that you're trying to do, or even the domain that you are in. So you can understand how that model has been trained, what kind of training data set is used, so you can make a choice about what kind of model that you want to do. So let's take a very simple model, which is Paraphrase Mini LM. So you can also see this model live on Hugging Face Model Hub. So all these models are also available on Hugging Face Model Hub, where you can go and try the model as well. So you can make that choice before taking the model. So right now we have we are going to take the model and build a base like a classifier thing, like that's why it's called CLF. So now the model is being downloaded at this point. So after this, we are going to take our data, and then we are going to train or fine tune the model, which is two-step process. One is fine tuning, the second one is fitting a logistic regression on top of it. For us, it's completely abstracted, we don't have to take care of it, but if you want to know the logic of how it is happening, you should always go back to this blog post and then read it. Also, the blog post has a Google Colab notebook which you can use. So at this point, the model has been the model has been downloaded. For example, if you are just simply using this model without doing anything, you can call it zero shot. You're just simply using a pre-trained model trying to do text classification. But what we are trying to do is take this model, on top of that use our data to train this, fine-tune this, and then fit a logistic regression that will predict positive or negative. So in that case, it's that it becomes a zero-shot learning. Now training data is downloaded. So what do we want to do? Now we want to do two things. We want to take this text, which we call document in here, and then we want to take either this or this, and we want to do like a label. So we have text and then equivalent label, because that's important for us to train. So what I'm doing is I'm taking the phrase and converting it to a list, and then assigning it to docs, and I'm taking the sentiment full, in this case positive or negative, and then converting it to a list, and then assigning it to the labels. So you've got docs and labels. If you want to see how it looks, docs look like this, labels look like this. So this is how docs and labels are. Now very simple fit method from like clf.fit, very similar like your scikit-learn model.fit, and we are just not calling it model, like you could have called it model as well. We are going to do the fitting with the text and their equivalent labels, docs and labels. Now it's going to take a little bit of time, as you can see, and because our data set is quite small, in this case 100 data points, it doesn't take a lot of time. But as you grow, as in when your data set, the training data set that you have got, becomes bigger, then this process would take longer. But the good thing is, if your training data set is bigger, then your model is also going to be better, because you're actually fine tuning, and the better you, like the larger data that you have to fine tune, the better it is than having a simple zero shot classification. So now once this finishes, so what you do in scikit-learn, so you load the model, you then train the model, which is the process of fitting. Like fitting and model training are same. Fitting, the word comes from the statistical. So you fit the model, and then finally what you do is you try to predict. So that's what you're going to do. So now we have fit the model at this point, and you can just like see what, oh sorry, it doesn't, like you cannot print it, that's my bad. Okay, so you can now at this point predict clf.predict, which is what you're going to do, predict. And what do you want to predict? We already discussed that we want to use the text from the test_50, and we want to predict. So I'm predicting it, and I'm assigning it to a new column inside test that says predicted. So we have got the full, original, actual, and then we have got the predicted value. So now, as in with any model evaluation, what you would do, we can go ahead and then build a confusion matrix for us to understand how it has worked. But couple of things before we move on to the next section, which is building the confusion matrix. One, this modeling purpose, this modeling process, what I just showed you, does not do cross validation. We have not split training data. We have not done any of those things, like, because I am leaving that as out of scope. My focus like for this particular video has been just to purely show you how to use SetFit and do few short text classification. So if you are going to do actual modeling using this tutorial, I would definitely recommend you to pay attention, data pre-processing, data cleaning, cross validation, which is quite important, and also the kind of base model that you select. I would definitely encourage you to pay attention to all these four things: what kind of base model you select, data pre-processing, data cleaning, and then cross validation strategy. Given that you have done all these well, and also now you have built the model, predicted it, now let's go ahead and see how the model looks like. I'm importing confusion matrix and confusion matrix display, and also pyplot, which is not required at this point at least. So I'm using confusion matrix, my actuals and my predicted, and then I'm going to select this, and then at this point we have got the confusion matrix. If you want to see how it looks, it's basically an NumPy array, and then you can see what you have below it. So it's 23, 5, 5, 19, so which means we can do this dot plot. Okay, so when you disp dot plot, because disp is where your chart is, you can actually see that your predicted label and your true label. So you like the diagonals that you see, that is your true. So you have correctly labeled the negative ones, you've correctly labeled the positive ones. Very small amount of mistake. I think we have really done a good job of taking a pre-trained model and fine-tuning it for our data set, and then done the classification. So if you want to, like, for example, re-evaluate like how the accuracy might change, now you can, instead of 100, you can take 200 and then change it and then see how it works. And then you can also introduce new evaluation metrics like AUC, F1 score based on your use case, and then try it. But I think at this point it looks good to me. At least like from what we set out to do is to learn why to use few short text classification, how to do few short text classification, also to do few short text classification, and then finally have a successfully working code. I'll link this Kaggle notebook in the YouTube description. Please check it out. If you have any questions, let me know in the comment section. Otherwise, once again, just to give credit, so thanks to, let me load the person. So thanks to PM Baumgartner. So sorry, Peter Baumgartner. So thanks to Peter Baumgartner, and also thanks to Moshe Washabalat for actually like Peter to create this SetFit package, and Moshe to come up with this even innovative approach that actually competes with GPT-3's fine-tuning. This is quite amazing. You should definitely read the blog post. I would love to see what your experience with the few short text classification with SetFit, and see you in the next video. Peace. Happy coding.